Hello everyone, my name is Devang. I hope that you all are doing well, and in this video we will be continuing our journey of the data structures and we will learn about Q. In the previous videos we saw like what is Q, and how we can just use the Q for the various purposes and what are the applications of Q. We saw about this. Now we will dive more into that of the Q and we'll try to implement the Q via the C++ language, and I will also provide the pseudocode side by that so that you can implement in any language. Okay, so before proceeding any further, let's talk about the STL representation of Q first. STL representation of Q. What does STL stands for? STL stands for Standard Template Library. STL stands for Standard Template Library. Now this library is provided by C++, like to give you some more handsome features upon various data structures so that you can implement in no time. Now it is a predefined class. It is a predefined container or class, whatever you can say that. Now it helps you to create data structures as soon as possible. Let's just think of an example. Like I have to just include the library hash include, and using namespace standard, and here the input output and all that. And as soon as I write this, like Q int Q, so I will get, as soon as I write this, I will get an empty Q to perform my functions upon. Now what does this line means? This Q is a template class. Which we are using. Whenever you see these kind of angular brackets now, always try to think like we are using some template kind of a structure. So we are by writing this line, we are getting an empty Q which will hold integers, and it would be a dynamic one. Why dynamic one? Because we have not specified the size yet. And let's say that we specify the size also, it will once, let's say that we specify the size of the Q to be 10 and we entered 11th element somehow. You remember the order of the Q is first in first out, right? Now so let's say that I have entered 10 element and now I am entering 11th element. So the size of the queue I just mentioned 10, but I am using this dynamic queue. What will happen? It will double its size. Yes, it will double its size and copy itself and make the copy of itself so that we can use a bigger data structure of that. Okay. So if we have to push anything, so it would be push 10. Like this is the Enqueue one. This is the Enqueue function. If you have watched my earlier videos, you would be knowing that what is the meaning of Enqueue and Dequeue. If you haven't watched, I will make sure that you get a recap upon here. Enqueue means pushing a data in that of the queue, pushing a data in queue, pushing a data or entering a data in queue, Okay, and if I write q.pop, what it will do, it will just pop the first element. Why first element? Because the order of the queue is first in first out. So it will pop the first element. Let us try to think of an example via this. I have taken q dot push 10, then q dot push 20, then q dot pop, then q dot push 30. So what will be the structure of my queue? Let us try to understand this first. Initially my queue would be empty, there would be no element in that. Then 10 is inserted into the queue. Okay, then 20 is inserted into the queue, right? And when we pop the item from the queue, this item will be popped out from the queue because the order is first in first out. Always try to, when you are solving the data structure queue problems, always try to think of like there is a doctor's queue. It would be very helpful for you to imagine that kind of structure. And then I push 30, so finally my queue would become like this, 20 and 30. So we have various functions which are available in the STL implementation. We have to just use the name of the queue, name of the queue dot the function name, and if the function involves some parameters and all that, then we have to write this. So what are the various functions? The first one is q dot push and element x. Then we have q dot pop, which would be popping the first item. Then we have q dot front. Now q dot front gives us the front element of the queue, which is present in that of the queue. Okay, and when we write q dot back, it would be helping in the back element of the queue. We are also having a function which is known as q dot empty. Now what q dot empty does? Q dot empty does simply tell us whether my size of the queue, is 0 or not. So this is the function of empty. This is the property of the empty function. Then we are having q dot size. Q dot size obviously tells the size of the data structure, which is known as q over here. Just remember a thing: push means NQ, pop means DQ. Now we will take this STL as our base and try to implement on our own. What I mean, we want to implement Q on our own, and what would be the function involved? First would be NQ, which is also known as push. Then we would be having DQ, which is also known as pop. That's why I just took the step to make you aware of the STL first, because then you will be having more clarity, like what we have to implement in our Q data structure. Then in that way we would be having a function which would be known as is empty. Okay, then we would be having a function which would be known as is full. Actually this work can be done by this function only. Then we will be having front, and yeah, pretty much as that of the STL. So now the question is that how can we implement? Now try to understand that Q is not a data structure which is available in that form which you are thinking. In the logical forms, we are only having two data structure, which is an array and the other one is linked list. All the other data structures which are beyond this are implemented either by arrays or either by linked lists. Now Q is an abstract idea. It is an ideology to represent your data. But how can you implement with this kind of a structure, either array or linked list? Yes, you are absolutely right. We can represent with array and linked list both. But we would be implementing via array so that we are getting a proper hinge, like how classical things work. Because if we implement via linked list, it would become tedious. Why tedious? Because linked list is this kind of a data structure. And the removal of the front node and pushing the pointers ahead and back would be difficult for us. So we would be following the array data structure implementation. Now in array data structure implementation, we can have various optimizations. How? We can use vectors. If we use vectors, we would be getting the dynamic arrays which would be having the bigger size, right? We could use circular arrays, that would be discussing in the next part of the video, but yes, we could be using the circular arrays as well. So yeah, this is pretty much the introduction, like how we will implement. Now let's implement it. Okay, so we will be firstly try to implement the Enqueue data structure, Enqueue function. Okay, so how can we implement Enqueue functions? Let us try to understand. Let's say that this is our empty array initially. And let's implement NQ and DQ both. So this is our array data structure. Now we want to just insert these items in the array: 100, 200, 300, 400. and I want to pop, I would be using cross sign to denote pop, pop and pop. And yeah, this is pretty much that. And while doing this function, I want to know my front element, I want to know my front element, and I want to know my back element. So this is pretty much which I want, which is asked to us. Okay, let us see the naive approach once. Let us see the naive. Naive means simplest thing that you can think, simplest thing that you can think of. Okay, what is happening? Okay, yeah, that you can think of. Now I always recommend to think of the naive one, naive first. Why naive? Because in an interview, whenever you think a naive approach, you will get the answer of the question. You will get the answer of the question. It is not optimized, nothing is optimized, but you get the answer of the question. Once you get the answer of the question, you can optimize it very quickly. But if you think from the starting that I have to optimize this and I have to think of the solution, it won't work. Okay, so let's think like how can we insert elements in the array. How can we insert elements in the array? Let's try to think of this part. Okay, so this is the order 100, 200, 300, 400. Let's try to put 100, 200, 300 and 400. Pretty much the first kind of a thing is done, which is enqueue. Enqueue is done, right? This part is done. Okay, now I have to dequeue. Cross means dequeue, right? Cross means dequeue. Now I have to dequeue. Now go back and think FIFO order implementation. FIFO order implementation. How can we do FIFO order implementation? Is there any way we can do FIFO order implementation? Like FIFO order means first in, first out. So how can I keep track of the element which was firstly in or firstly out? There is no need. Why there is no need? Because obviously I am using the indexes of the array which are in the order of the insertion, So when I am asked to dequeue, I will remove 100, remove 200, remove 300. In the first video of our lecture series, we discussed how we can delete an element from the array. If you do not have watched the videos, let me help you to revise that. What we can do, we can move this element upon here, or we can just there are various, but let's think of the naive ones. Simple. So enqueue and dequeue have done. Let us try to understand this more clearly. See, I was having initially array as empty. When I inserted 100, this element become my front element as well as my back element, right? I am using naive one only. So do not confuse over here and try to think like what I am doing upon here. Okay, done. Then I inserted 200. So this is 100. This is 200. Now think. This is a doctor queue. Initially you was person 1 and you was person last. You were the person 1 and you were the person last because there was no person behind you. After some time there comes a person. So now you are not the last person, you are the first person because there is the last person behind you. So this is the same thing which we will use here. This becomes my front element and this becomes my back element. Now I inserted 300. So it would become 100, 200, 300. This is my front element and this is my back element. Can you see a relationship? Yes, we can see a relationship that my front element is always the zero indexed element. Okay. And the back element is always the last element, which is size minus 1 indexed element. I am again saying I am using the naive approach. We will be seeing the circular implementation as well. But before that, by using naive approach, we will try to arrive on the solution once. So like we are clear of these terms. Now we are clear of these terms. So what are the data structure and what are the things that we will be needing to implement? The first one is the array itself, correct? Another one is the size of the array, correct. Third one is the current size, because let's say that we initialized our size to be 100 and this is this, so this is the full size and the current size, correct. Okay, and is there any more thing which is required to implement this? No, only using three things we can implement. So let's try to implement the enqueue dequeue function once. Okay, so let us um, let us use the ruler once. Let us use the ruler once so that we can write our code cleanly and okay. No, yeah, just give me a minute so that, yeah, no, the line is not straight. Okay, so firstly would be having hash include bits slash std++.h. Why? Because if we include this library, we would be not requiring to include any other library. Then we would be having using namespace standard, and we will try to implement this with the help of classes. Okay, so class Q. Now try to think this line which I am saying. We will make the members as private one. We will make the members as private one. Why? Because we do not want the members as, yeah, so because we do not want the user to access our members, and in classes the members by default are private. Okay, so just remember these 2 points. So let us make the members. First one would be my the capacity, which would be the size of the capacity would be the maximum size if the queue can hold. The current size and an integer type pointer array. Why integer type pointer? Because GNU C++ compiler allows you to use the dynamic arrays which would be giving the size as input, but the maximum ones don't. So we would be using the classical method. Then I would make a public. Then what we need? Then we would be needing a constructor. Yes, then we would be needing a constructor in text. Why constructor? Always try to remember, we always initialize everything inside constructor, everything inside the constructor of the class, inside the constructor. So if you have not used the constructor, it would do the default constructor thing. So here what I will do, I will say that my capacity is equals to x. My capacity is equals to x because this should be the maximum size. My current size is equals to 0. My current size is equals to 0, and my array is equals to new, the dynamic one, integer of size x. Okay, so this is the base one. Now let us proceed to the enqueue function. So let us try to implement the enqueue function. Now let me just rub this part. Okay, so yeah, so here we are having the enqueue function. What this enqueue function states, void enqueue, we would be having our data, int data, and enqueue means pushing an item, enqueue means inserting an item. Okay, enqueue means inserting an item. So always try to think of the edge case first. Always try to think of the edge case first. Now the edge case would be that my queue is already full, so I cannot insert anything. So I would check that, hey, if my current size is equal to that of my size, if my current size is equal to that of my size, then return. Else what I will do, I will say that my array of current size is equals to x. Array of current size is equals to x, which is the, sorry, here is data. I have inputted data. So array of current size is equal to data and size plus plus, simple. Now let us just try to implement the deleting function, which is deck function. Okay, let me just rub this part. Okay, yeah, so I am having like void dequeue. I want to delete an element from the queue. Now try to think of this way of deleting. We are using the naive approach. Yes. Try to think of this way of deleting. Yes. We have to just push this over here. We have to just push this over here. We are following the FIFO manner. We are following the FIFO manner. So firstly, we have to check that if my current size is equal to 0, then return, because there is no fun in returning in deleting the any element of from queue which is already empty. And then if that is not the case, then for int I is equal to 0 and I is less than my current size minus 1 and I plus plus, and what we will do, we will simply just move array of I is as array of I plus 1, and we will do size minus 1. We will do current size minus minus. So yes, this is pretty much the code. I hope that you understood till this part of the video. If you have any doubt, make sure to comment it out, and we will meet in the next part of the video. We will be seeing some more things upon Q. Okay, thank you.